All right, let's get into the greatest common factor. Welcome back to your favorite Pre-Calculus 1 expanded course. Get into the greatest common factor and factoring by grouping. If you're finding the greatest common factor of two numbers, like let's say for example 16 and 20, you can probably in your head figure out that 4 is the greatest common factor of those two, right? But if you didn't know, what you want to do is you want to break it down into their prime numbers, product of all their primes. So 16 is 4 and 4, but 4 is 2 and 2, right? So the factors of 16 are 2, 2, 2, and 2. Factors of 20, 4 and 5, but I know factors of 4, or the factors of 4 are 2 and 2, right? So their greatest common factor would be the product of their shared factors. So you notice they both have 2's. So I put a 2 there. And they both have another set of 2's. So 2 times 2 looks like the greatest common factor of 16 and 20 would be 4. That's their greatest common factor, right? So this makes it a little easier, because if somebody asked me what's the greatest common factor of 88 and 484, I'd be like, I don't know. So I'm going to have to break it down, right, into their prime numbers. So I say, well, 88 is 8 and 11. 8 times 11 is 88, right? 8 is 2 times 2 times 2. 11 is a prime already. 484 is, let's see, that'd be 4 and 121. And I know 4 is 2 and 2, and 121 is 11 and 11. All right, so the greatest common factor of these, they both have a 2, both have another 2 they share, and they both have an 11. So it looks like the greatest common factor of these would be 2 times 2 times 11. So 44. You could do that for 100 as well, right? We know 100, 10 times 10, or 4 times 25. 14, factors of 14, 2 and 7. 35, factors 35, 5 and 7. So if I'm looking at this, I'm like, geez, they don't all have a 2. That's my greatest common factor here. Well, they don't all have a 2. That's a problem. They don't all have a 5. They don't all have a 7. My goodness, what's the greatest common factor then? Well, the only number we didn't write is 1. All of these times 1, right? So they only shared, if there's nothing else, our GCF is 1. Their greatest common factor is just 1. Now let's do it with some variables now. 30x to the 4th, 130x to the 6th, 60x to the 9th. So we got 30, I got 3 times 10, so 2 and 3 and 5, 6 times 5. And then I got 4 x's, 1, 2, 3, 4. 130 x to the 6th. So 130 is 10 times 13. So I got 2, 5, and 13. I got 1, 2, 3, 4, 5, 6. 60 x to the 9th. 60, I got 6 times 10. So I got 2. All right, so it looks like our GCF here would be, they all have a 2. It looks like they all have a 5. And then, how many x's at most do I have this year? It looks like they all have at least 4 x's. So 1, 2, 3, 4. So our GCF here would be 10x to the 4th. Let me make this the next 3 U-try problems. And pause the video here. It looks like on this one, if you wrote that out, they'll share a 2, they all share a 5. They do not all have an A, and they do not all have a B, right? So no variables are in that greatest common factor. Go ahead and try these next two. If you pause that video as well, both of those two, we'll scratch those out and check them. Hopefully once you wrote those as a product of prime, you see they all have a 2. They all have another 2 they share. Looks like they have another 2 they share. And then at most, the top one has 5 x's, the bottom one has 3 x's. So at most, we share 3 x's. So our greatest common factor would be 8x to the third on that one. Notice this one after I factor it all out. Not all of them have a 3. Not all of them have a 7. Not all of them have a 2. Not all of them have an A, and not all of them have a B. So what's my GCF? I say, well, everything is multiplied by 1. I guess my GCF is just 1 on this annoying problem here. All right, so if we're using this to factor then, so if we're factoring 30x plus 42, if we're factoring that, let me write that, 30x plus 42, I'm thinking to myself, well, what's the GCF of 30x and 42? Well, 30x is 5 and 6, so 2, 3, and 5, and an x. 42, I got 6 and 7. So notice they both share a 2, they both share a 3, so our GCF is 2 times 3, 6. So I take a 6 out of both of those, and what would I be left with? Well, I'd be left with 5x, because remember I got to distribute this back and have 30x, right? So in other words, 30x divided by 6 is 5x, right? And 42 divided by 6 is 7, positive 7. And that's how we factor that. Again, you can check it. Just make sure that you distribute that back. 6 times 5x, 30x, plus 42. And similarly for this next one, go ahead and try that. So on this you-try problem, you should have recognized that 14 was the greatest common factor. So 28x divided by 14 would be 2x. 70 divided by 14 is a plus 5. You can distribute that back and check that. And let's say you didn't scratch it out. And let's say you thought it was 7. Right? Well, hopefully you're looking at this 4 and 10 and recognizing you can take a 2 out of both of those, right? So you'd still have the 7, but you got to take a 2 out of those other 2, and you'd be left with 2x plus 5. So either way, right, you should end up with that 14 out front times the quantity 2x plus 5 if you're going to remove the greatest common factor when you factor that, right? Now let's look at this negative 3x squared minus 21x. I want to take out a negative 3x. I could take a negative 3x out of both of those. That's their GCF if I factor out a negative as well. And I'd be left with x plus 7. Again, check it, right? If you're not sure, make sure you check the thing. Negative 3x times x plus negative 3x times that 7. You get negative 3x squared minus 21x. That's what we started with. So we did factor that correctly. Here's another one. 63x cubed plus 21x squared. Hopefully you recognize that 21x squared is their GCF. All right, that's the first thing you want to go with. And you'd be left with a 3x plus 1. Again, you'd check that, right? Notice if I distribute that back, I have the original 63x cubed plus 21x squared. Notice on this next you-try problem, the leading coefficient is negative. So make sure you take out a negative whatever on this. Right? I'll go ahead and pause the video here. Should have factored out a GCF, that negative 18x squared out front, and left with that 3x plus 1. All right, let's do if we have 3 terms. X to the fourth, x to the fourth, x. They all have an x in common. So I'd be left with 6 x's, 3 x's, and a plus 1. So that's my factorization right there. X times the quantity x to the 6 plus x to the third plus 1. How about this 4x squared minus 12x plus 32, hopefully you recognize that you could take a 4 out of each of those. That's your GCF. And you'd be left with an x squared minus 3x plus 8. And this remaining trinomial, you can't factor that any further, so we just stop right there. At x squared minus 3x plus 8, we're done with that one. Right, go ahead and pause the video on that 8x squared plus 24x plus 88. So hopefully you took an 8 out, left with x squared plus 3x plus 11. I would test and make sure, can I factor that anymore? I cannot. All right, backwards FOIL there. So we just circle it right there, we're stuck. Now notice the leading term's negative, so I'm going to factor out a negative. Let's see here. Negative 8. They each have an x, at least one x. And they each have at least one y. So negative 8xy. And what would we be left with? I took a negative 8x out, but the first term is x squared y to the cube. So I'd have to have x and y squared. Next it would be plus 2y. And then it'd have to be plus 6. Again, be very careful. Go ahead and distribute that back and check that, right? When I distribute it back, you should end up with the exact same thing there. And why don't you try that next one that's kind of similar. Should have factored out 5xy, and you have that quantity x minus 6y plus 9 on that one. This one's a little bit different now. Notice I have x times x plus 19 minus 16 times x plus 19. So I got two terms here. I got this term, I got minus that term. All right, I got two terms. But notice they both have a shared x plus 19. They both share that x plus 19. So I'm going to take out an x plus 19. And what would I be left with? I'd be left with x minus 16 is what I would be left with. This is kind of like, let me write it another way. Imagine x plus 19 is a. It's kind of like taking a out of both of them. They have that greatest common factor of a. The a is just x plus 19, right? They share an x plus 19 factor, okay? This is called factoring by grouping, by the way. It's just set up nicely so you can see that they have a shared 2x plus 5 in this case. So I would be left with 8x plus, and that's a 1 right there. They don't write the 1, right? So x plus 5 times the quantity 8x plus 1. Let's do this. You try a problem. Go ahead and pause the video. Should end up with that on that you try a problem there. They both share that x minus 4. So that leads us into another one. What if we share an x plus 5? I have two x plus 5s. This one's only got one x plus 5. But they both definitely have an x plus 5. Like maybe you want to write it like this. X plus 5 minus 11 x plus 5. So they both share that x plus 5. I'm going to pull that out front. And then what am I left with? Well, I still have an x plus 5 from the first one and a minus 11 right there. All right, and I can combine the 5 minus 11 in black there. So I have x plus 5 and x minus 6, and I'm all done with that one. One below it says, notice it says explicitly, factor this by grouping. So now, oops. Do it by grouping. When do I know I'm doing it by grouping? You're going to have typically going to have 4 terms. That's kind of the giveaway. See how I've got 1, 2, 3, 4 terms there? Okay, so that's when this factor by grouping oftentimes comes into play. And what you do is you look at the first two. All right, x cubed and x squared. What's their GCF? They both have an x squared. If I take an x squared out of those, I'd have x plus 1. Now let me look at the next two, 15x and 15. What can I factor out of those two? Hopefully you say 15. That's right. Now we're at the same step we were before. They both share an x plus 1. So I take that x plus 1 out. I'm left with x squared plus 15. And that's how you factor by grouping. Again, you got 4 terms like the one down below. Let's do that next one. You got 4 terms. You're probably going to be factoring this by grouping. Look at the two that have a shared factor. See what you can factor out. Look at the next two. What can you factor out? And then go ahead, factor out the quantity, the factor that they share. What are you left with? And let me have you guys try this last one. Go ahead, check yourself. You should end up with an x minus 2 up front times quantity x squared plus 17. Appreciate you guys taking notes. Actively participating. See you next time.